We have a hard problem today. Given numbers, we want to find each pair GCD, like GCD 1, 3, and so on. So we have n square pairs, and after that we have to sort them, and after that we want to answer the queries, where each query is the position in this sorted GCDs list. Okay, personally I didn't solve this problem. It is a hard problem, and the count of numbers is 10 to the power 5. I'll try to explain the solution that it is not mine, but what I understood from it. So imagine we have we want to first count these GCDs somehow, and first of all we know about the duplicates. That means we have to shrink them. So what we can do is to find the frequency of each number, like this, and after that we have for each GCD. So the GCD has upper bound. So if we have some maximum value in this list, the GCD would be less than the maximum, because unless we have two maximums, and then they're just GCD equal to the maximum itself. So that means the GCD is also 10 to the power of 5, and we iterating from the top GCD up to the bottom. And for each GCD, we can count how many pairs. So for each GCD, answer the question how many pairs we have. This is a question, and let's think about it more closely. So imagine we have number 6, for example, and we want to answer the question how many how many pairs we have that has GCD of 6. And the GCD of 6 is some number like 6 and n times 6. This would be GCD. So that means we can just go for multipliers, like we count forward. So that means if GCD is a greatest common divisor, that means it forms the following numbers like 12, 18, and so on. So this is 2 times 6, this is 3 times 6, this is a 4 times 6, this is a 4 times 6, and so on. So after that we counting so how many numbers we have from our array, and this is a question of the frequencies. So the frequencies are like this, and we're doing the sum of them. So this is the sum, and this would be answers for the GCD equals 6. This is how many pairs. This is a question of how many pairs we have, but this sequence would include also for answer for the GCD of 12, for example, and we want to exclude it from this, and GCD of like 18 we want to exclude from this. So only to not overcount of GCD of 6, because if we don't exclude, we have the same pairs of the same numbers that give us same, for example, number x equal GCD of 12 and GCD of 6, so this pair will be counted twice, so we want to exclude this. And that means if we have k is the number of pairs, it is a sum of frequency of all numbers in multipliers, like from a up to the maximum, and this step a, this is just row for this sequence. Then the number of pairs is k times k minus 1 divided by 2, which is the number of pairs. And after that we're doing exclusion. So exclusion is the previous. So we have g of a, example, and this would be g of 2a minus g of 3a, and so on. So this sequence goes and goes, and it is sum of g of multipliers, like from 2a up to the maximum, step 2. This is a formula for the pairs, and basically this g is number of pairs for GCD, like g of GCD equal number of pairs. Okay, we have number of pairs, and then our query is just, so we have number of pairs like 1, 1, 1, 2, 2, and so on. This is g, and after that we computing the prefix sum. So basically we counting that this is 1 pair, this is 2 pairs, this is 3 pairs, this is 2 plus 3, 5 pairs, this is 7 pairs, and how many pairs of sum q is that we just found this position, and like this would be the answer. Okay, let's look at the code. This is binary search, by the way, and we can do binary search because the prefix sums always increasing. Binary search. This is the code that was accepted. I just copy pasted or just typed it from some solution of Lee. Okay, this is frequencies, and this is a maximum. We can use constant 10 to the power of 5, but it will be slower. That's as we're going from big to small. Why? Because this calculation of the GA, it's a new one, and we want to know G2 times A. So this is a bigger, should be known. So we go from the bigger to the smaller. So A goes from maximum down to 0. That's why we can do this. Take A and then to use previous result. Okay, that's it. We using counting multipliers by just doing plus number itself and counting the frequency if we have one. After that we use this formula for the pairs, and then we subtracting this as a multipliers of already calculated the GCD of A, and we do minus GCD of 2A, and so on. And after that, we're doing prefix sums, and then we're doing binary search. And the binary search can be one-liner like this. You just have to play with this equation to make it work. And obviously we do inversion to save this -1 operation, because binary search didn't return exact position. If you write it like this with if, it only returns missed position. Okay, and this is a Rust. The same story. I use maximum frequency and then go from the maximum. Use step by, count frequencies, and then use this arithmetic sum minus bigger multipliers. Okay, the hardness of this problem is not the code itself, it's that you looking at this like numbers, and you don't have a clue how you can go from the numbers to pairs if you have this big count of numbers like 10 to the power of 5. And basically the cheat code was to know that you can go from the GCD. So you go from the GCD, for each GCD you go, and you can compute how many GCDs you have, how many multipliers you have, or how many divisors you have. So basically the cheat code is this formula where you're counting the sum of frequencies, and this is a sum of frequencies of multipliers. And this is a clever idea how you can pre-calculate the number of GCDs. Okay, that's it for today.